Okay, so let's do a little bit of what we were doing yesterday. Let's match each function with its graph. So who can explain to me 1, 2, or 3, whether it's A, B, or C? How about number 1? Okay. Number 1 matches what? Yes.
Number 1 matching A, or C.
C. Okay. So number 1 is C. What makes number 1 C?
There's the 1 times 5x and the 1 is the y-intercept.
The 1 would be the y-intercept. That's in front of that 5. Perfect. And you got a y-intercept there. All right. What about number 2? A. Good. So what's the difference between A and C? No, it doesn't go up steeper. All it's doing is translating. See how it's the same steepness? Right? So what x is having an effect on is that base, 5. Well, the bases are the same, therefore the steepness is the same. All it is just translated down 1 here and up 1 here. See that, Ryan?
Yeah.
Evan? So number 3, what's different about number 3? It's falling. It's the inverse, right? It's still the same steepness, but now it's falling, or it's an exponential decay, right, rather than a growth. So it looks exactly the same, only it's reflected across that y-axis. Perfect. That's kind of our behavior of our graphs, what's happening. All right, what can you say about the following graph? So take a look at this, discuss with each other. We've got a lot of stuff going on up here. I want to start piecing it apart, okay? Okay, so I heard a lot of what I like. So, who's got something for me? Okay, let's do something. Good. This one is reflected over. What do we call this then? The green line? Not axis of symmetry. Line of reflection. Good. There's a line of reflection. This graph is reflected over to this. What else do you see? The coordinates are switched. Remember that? So if this one's 0, 1, this one's 1, 0. Remember? That was one thing that we did when we were trying to find. That's going to be my next question. What are these graphs? What do we call them? Okay, this one's exponential, right? And what is this one? Since it's reflected over y equals x, what is this graph compared to this graph? Nope, it's not decay. Talk about what you already know. Not about what any new information. What do you already know? If this line right here, if that point switches, this x and the y switch, what do we know about that? We did it in, I think, chapter 6. Inverses. They're inverses of each other. Okay, so remember, there were 3 different ways we can find inverse functions, correct? What's the first way, which is right here? If I have this graph right here and I tell you to graph an inverse function, how would you do it? Switch the points, the x and the y's, right? So this one is switched. 2, 4 is now 4, 2. 0, 1 is now 1, 0. What was the second way that we could find an inverse function, but we can do it algebraically? Okay, the equation. What happens to the equation? So here's the equation. Okay, that's the next one. I hear it, Claro? Exactly. The second way you can find the inverse function is to switch x and y. So what would this one be? X equals 2 to the power of y. Remember that? So we were dealing with lines like this. Y equals 2x plus 3. How would I write that inverse function? x equals 2y plus 3. Remember that? We switched the x and the y. It's the same thing as switching the points, the x and the y points. Does anybody remember the third way? I'm holding up a 5 and I mean 3. The third way.
It was F of X or whatever, where you plug in equations to each other.
Okay, does anybody remember what that's called, where you're plugging in functions into other functions? What was it called? Composition of functions.
Oh, yeah.
Remember that, to find out if the equations are
It just made me think.
inverses? You use composition of functions. See how it's all pulling together? Okay, so this is what I want to say about this. This is what we learned yesterday, right? This is an exponential function. All right? This is its inverse. In order to find the algebraic equation for it, you switch the x and the y. Everybody with me so far?
Yeah.
Okay. I will be able to evaluate logarithmic expressions is what we're doing today.
That's a big word.
It is a big word. I have to keep making sure I spell it correctly too. Okay. So yesterday I did y equals b to the x. Correct? Looked like this. Right? Sorry, that one's a decay. Looks like this. That's a growth. So I just showed you right now, what would x equals b to the y be? Be the inverse, right? The inverse of this is this. Specifically, we call this a logarithmic function. Okay? Here is how I have this. Actually, Ms. Wiz told me that when she reviews logarithmic functions with her Prob and Stat kids, they like to see it like this. Log base x equals exponent. Okay? We're going to explain what that means. Okay, so let's recap. These two are the same thing, written differently. Ms. Watkins came up with an awesome analogy. Standard form and slope-intercept form, aren't they the same line?
Yeah.
They're just written differently, right? These two are the same thing, just written differently. I came up with a more simplistic analogy, which was mixed numbers and mixed fractions and improper fractions. They're the same thing, just written differently, right? So this and this are the same thing. So let's start here. What's this called? Exponential. And what is this compared to this? It's inverse. And what is this compared to this? Just same thing, only written differently in logarithmic form. So today we're going to learn how to go from this form, exponential form, into logarithmic, and from logarithmic into exponential.
Yeah. Hi, I was just here, and then on my...
Okay, so I think what we should do is jump in. All right, so pencils down. Pay attention to what I'm going to do. All right? Because it's going to look foreign for a second here. All right, so logarithms equal exponents. So log bx equals y, the exponent. Exponentially, it looks like this. The base to y equals x. Follow? I'm going to do this one more time. So exponential function is y equals b to the x, correct?
Yeah.
The inverse would be x equals b to the y, correct?
Oh, yeah.
Right? Kind of helps when you just keep writing it over and over again.
Well,
Okay, have a seat. So, we'll rewrite this. X equals b to the y. So, here's your base. Here's your base. That's why we have base written here. I'm just going to concentrate on base and exponents. Here's your exponent, right here, right? Here's your exponent, exponent. All right, so first thing I'm going to highlight here is my base. I'm going to begin with my base. My base is 4. My base is 4. My exponent is, I did it opposite. Shoot. There we go. My exponent is 2, right? Logarithms are exponents. Logarithms equals exponent. Okay? So 4 to the 2 equals 16. This form is this. This is logarithmic form, exponential form. Okay, I'm going to do another one, then I'll have you write both of them down. Okay, let's see if we can do this more smoothly. I'm going to identify my base. My base is right here. This is my base. My base is 3. Logarithms are exponents. So my exponent is -3. -3 equals 1 over 27. Makes sense, right? 3 to the -3 is 1 over 27. Okay. Question? About that time, right?
Every day at the same time.
Annual, or no, it's daily. It's the 2 o'clock fire alarm in the S building. Okay, go ahead and write that down. Bing. Okay, let's try it the other way around. Pencils down again. Logarithms are exponents. Okay, so I have I'm going to turn exponential form into logarithm form now. Okay, log. The next, that subscript is my base. So I'm going to identify my base. My base is 4. That didn't work right. My base is 4, so I'm going to write 4 equals, logarithms are exponents. So what's my exponent? 3. You don't have to do it like this. This is the way I do it. Because actually, I feel like this way is harder to fit into this way than this way to that way. Does that make sense? So I'm going to do that. I'm going to skip the x part. I'm going to say, here's my base, there's my exponent, and then I'm going to fill in the whole 64. Okay, I'm going to do another one. Ready? All right, turning this into a logarithm. Log, what do I identify first? My base. Here's my base, 125. Then I'm going to identify my exponent. 1/3 is my exponent, right? My exponent, just like my exponent is here, my exponent is here, my exponent is here. See that? My exponent is here, my exponent is here. Because logarithms equal exponents. Just keep telling yourself over and over again. Logarithms equal exponents. Yes?
Is the log cancel like a number? Is like a pi?
We'll get there.
Okay.
Okay? I don't want to confuse you and answer any more than that. All right, so what goes here? 5. Yes.
So you have that 1/3 is the exponent. So if you were going to go further and like reducing it, that would be like the cube root instead of like
No.
square root. So you just keep it like that always?
Yes.
Okay.
You're going to keep it like that. Yes.
And you ever have negative exponents?
Yes.
What do you do with this?
Let's get there. Okay. How are we doing so far? Good. Okay. I want to deal with the negative exponent part during your homework time, because I want to answer questions from yesterday that have negative exponents in them that I'm sure people have questions on. Sound good? Okay. So, oh, I'm sorry. Make sure you have that written down. Recording. All right, so let's evaluate an expression that's in logarithmic form. So I'm going to take it from logarithmic form and turn it into exponential form first. So I'm concerned with I begin with my base. Begin with my base, then talk about my exponent. Base, exponent, base, exponent. So what's my base? 3. What's my exponent?
You don't know yet.
I don't know yet, but what is my exponent normally? Y. Remember? Log bx equals y. Okay, so then what can I write here for my exponent? Y equals 81. Do you see where this is going?
And then you figure out what the y would be.
Yes. So I see, I'm going to do this a little bit differently than I did yesterday. Yesterday we just talked about 3 to the what makes 81, right? Well, let's just talk about if you didn't know. You have absolutely no idea and you don't have a calculator to use. You're not screwed. Let's talk about what you do know, Evan. So 3 to the y. Now, what do you recognize 81 being? It's a square. What's the square in there? 9. 9 squared equals 81. Correct? Then I could do 3 to the y equals 9 is really 3 what? Squared. Does everybody see how I substituted that? I have 9 squared is 81. Well, isn't 3 squared 9? So 3 to the y equals 3 to the what? 4. So what does y equal? 4. That was yesterday's homework, right? So y equals 4. Therefore, I could actually evaluate this now. Log 381 equals 4.
This is going to get even harder than
This is as hard as it's going to get today.
today. Tomorrow
Today.
is going to be turned into graphing of some kind. I'm going to cry.
Okay, Ryan. All right. Who would like me to do this whole process again, or would you like to try it?
I want to try it.
Try it. Does anybody know the square of 256? 16. 16 squared is 256. And remember, Mitchell, we did that over and over in 7th grade? Squares over and over and over.
Didn't you have to do like a little, like a time quiz thing where
We would do time quizzes over and over again. Squares.
you did 11 and 20 and had to go to
Yep. Okay, so try that one. 256 is 16 squared. And it all, try it, stuck. Okay, so what am I going to begin with? The base. What's the base? 4. So 4, then what? I go from the base to the exponent. What's the exponent? Y. 4y equals 256. 4 to the y equals, what's the square in 256? 16 squared.
You have to go through like the small breakdown with like 16 squared and do all of that.
Well, we don't need to go much further, right, Ryan? Because what's the square in 16? 4 squared. Squared. So 4y equals 4 to the what? 4. Therefore, y equals? Y equals 4 again.
Is this going to be common?
No.
Oh. I could just put 4 in the text a lot and hope I get good credit.
Y equals 4, therefore, log with a base 4, 256 equals 4.
Do you expect us to use the document when we do it on like the section on Word?
Unless you want to write therefore.
That's a good point.
Okay. Questions?
I'm good.
Okay, let's talk about, let's get you back your, let's do our closing thought, and then I'll pass back your homework. I need your attention, please. Freeze. What did you learn today? Somebody raise their hand and tell me what they learned today. Evan? Logarithms. Where do logarithms come from?
inverses of an exponential function.
Very well said. The inverse of an exponential function. Guys, I need your attention. Logarithms are just what?
Inverse.
Our logarithms equal exponents. On your assignment sheet, to evaluate a logarithm, I must first what? Base. It's all about the base, right? Okay, you guys, so record that. Good job.